12 mines, 1 sweep. The math runs in Iran's favor as long as the IRGC can operate its fast boats in the Strait, which they can, because no surface ship wants to operate in the minefield either. The Sea Dragon is winning the physics problem. Iran is winning the time problem. And the resolution of that tension is what determines whether Hormuz opens in weeks or months. Here's what this analysis does not mean, and the distinction matters. The MH-53E is not the only tool clearing Hormuz. It is the primary mine-sweeping asset. The ANAQS-20A sonar is working alongside it, finding and mapping bottom mines that the sled cannot directly sweep, because bottom mines in shallow water can sometimes be neutralized by the sonar-directed approach. Locate precisely, send a diver or remote vehicle with a shaped charge, detonate in place. That process is slower than sweeping and more dangerous, but it works for bottom mines in water, shallow enough for divers and remotely operated vehicles to operate safely, which the inner portions of the strait mostly are. The honest picture is a layered clearance operation. The Sea Dragon sweeps influence mines across the primary tanker corridor. Sonar systems map bottom mine locations. Explosive ordnance disposal teams neutralize confirmed bottom mines individually. The LCS mine countermeasure ships coordinate and provide the command and control architecture for the whole operation. The Sea Dragon is not doing this alone. It is doing the part that nothing else can do. The second honest caveat is timeline. Mine clearance at this scale, in these conditions, against an adversary actively attempting to reseed the field, does not produce a clean result quickly. The Navy's operational mine clearance doctrine does not aim for 100% certainty in an active threat environment. It aims for acceptable risk, a swept lane where the probability of an undetected mine is low enough that an escorted convoy with a minesweeper in the lead can transit with an acceptable risk profile. Acceptable risk is not zero risk. The insurance market understands this, which is why, even with active mine clearance underway, commercial insurers have not yet resumed writing policies for Hormuz transits. The strait does not open when the last mine is cleared. The strait opens when the insurance market believes the risk is manageable. Those are different thresholds, and the insurance market's threshold is higher than the Navy's. Now step back from the helicopter and look at the full picture of what Iran accomplished with a weapon that costs less than a mid-range car. Before Hormuz was mined, the Navy's problem was fast attack swarms, shore-based missiles, and ballistic missile threats. All of those problems were addressed by the combined arms approach we covered in the A-10 video. Air Force, Army, Navy working the threat simultaneously. The fast boats were engaged. The shore batteries were neutralized. The missile factories were rubble. Iran still has 2,000 mines in the water. Here is the asymmetry that makes the mine Iran's most strategically durable weapon. Every other weapon Iran fielded in this conflict, the fast attack boats, the shore-based missile batteries, the IRGC drone swarms, could be located, targeted, and destroyed. They had operators, they had launchers, they had supply chains, they emitted signatures when active. They could be killed. A mine on the seabed has no operator. It has no emissions. It does not move. It does not communicate. It does not consume fuel. It does not require maintenance. It has no logistics chain to interdict. It sits in the silt and waits. You cannot bomb a minefield from the air. A 500-pound bomb detonating in water creates a shockwave that may or may not sympathetically detonate mines within 50 meters. In a field spread across 11 kilometers of shipping lane, air-delivered ordnance clears a negligible percentage of the threat while churning up the seabed in ways that make subsequent sonar detection harder. You cannot sail a warship through to clear the lane. That is the point of the mine. You cannot send autonomous systems that are too small to trigger influence mines and too slow to cover the required area before Iran reseeds what they clear. You send the Sea Dragon, the helicopter built in 1969, flown by pilots born in the 2000s, doing passes 25 feet above the water, feeling the detonations below, and doing it again tomorrow. Here is the convergence equation. Iran spent 40 years studying how to stop the U.S. Navy. They built fast attack swarms. They built shore-based missiles. They built ballistic missiles. They built the Khalij Fars. The Navy found an answer to all of it. Then Iran spent $100 million seeding 2,000 influence mines across a 6-mile corridor. And the answer to that was already in the Navy's inventory. It had been there since 1986. The Navy tried to replace it for 30 years. Physics kept saying no. The mine that costs $50,000 and takes 4 minutes to lay is still in the water after the $13 billion carrier group has been operating in the region for 6 weeks. That is the equation Iran solved. Not how to defeat the Navy, how to give the Navy a problem that victory cannot solve quickly. Because the strait does not open when Iran is defeated. Iran has already been defeated militarily by every conventional measure. The strait opens when 2,000 objects sitting silently on the seabed have been located, triggered, or neutralized one by a helicopter older than the pilots flying it. This is not a story about a helicopter. This is a story about what happens when the simplest weapon meets the most complex military force in history. And the simple weapon wins the time war even after losing everything else. The United States Navy is the most powerful naval force ever assembled. It has defeated Iran's surface fleet. It has suppressed Iran's air defenses. It has neutralized Iran's coastal missile batteries. It has eliminated Iran's submarine capability. By every conventional measure of naval combat, the United States has won. The strait is still closed because of objects that have no electronics, no guidance system, no propulsion, no operator, and no communication link. Objects that Iran paid $50,000 each for and laid from speedboats at night. The lesson is not that mines are undefeatable. The Sea Dragon is clearing them. The lesson is about time. Modern military power is measured in decisive action, precision weapons, fast targeting cycles, rapid effect. The American way of war is designed to compress time, to move faster than the adversary can adapt. The mine removes that advantage entirely. The mine does not adapt. The mine does not respond to speed. The mine sits and waits and requires the slowest, most methodical, most painstaking process in modern naval warfare to neutralize. A helicopter flying at 25 knots, a sled dragged through the water, a detonation below, a note on the chart, another pass. Every nation with a coastline and a grievance watched what 2,000 mines did to a $40 billion naval operation in the world's most important shipping lane. They watched a $50,000 weapon hold a $13 billion carrier group at bay for weeks, not by threatening the carrier, but by threatening the corridor the carrier exists to protect. The lesson has already been learned. It is being applied right now in planning staffs from Beijing to Pyongyang to Caracas. The mine is the great equalizer of naval warfare, not because it defeats the Navy, because it forces the Navy to fight on a timeline the mine controls. And the only machine in the American inventory that can reclaim that timeline is a helicopter that was designed before email existed. Go back to where we started, 2,000 mines. 6 nautical miles of shipping lane, $40 billion bleeding from the global economy every week. The Navy has autonomous drones, AI-guided sonar, unmanned mine hunters engineered specifically to solve this problem. $8 billion spent over 25 years building systems designed to make the old helicopter obsolete. Every single one of those systems can find a mine. Not one of them can sweep an influence mine, because sweeping an influence mine requires generating the acoustic, pressure, and magnetic signature of a 300,000-ton ship. And the only way to generate those signatures at sweep intensity is to fly a 36,000-pound helicopter at 25 feet above the water, towing a 7,800-pound sled on a 150-foot cable, pulling a 1,000-foot magnetic loop through the Persian Gulf at 25 knots toward a mine that will detonate when it decides the signatures match. That is not a technology problem the Navy has not solved yet. That is a physics problem, and physics does not negotiate. So every morning, the MH-53 Sea Dragon, a machine designed in 1969, first flown in 1974, entered service when Ronald Reagan was president, launches from a Navy ship in the Gulf of Oman and flies toward the Strait of Hormuz. The pilot was born in 2001. The aircraft was designed before his parents met. He flies his lane at 25 feet. He feels the detonation below. He notes the position. He turns around and flies it again. The strait does not open today, but it is one mine smaller than it was yesterday. One mine. One pass. One helicopter older than everyone flying it. And it is the only machine on Earth that can do what needs to be done. If this changed how you see the mine clearance problem at Hormuz, subscribe to War Vision and drop sweep in the comments. We are tracking this story until the strait opens. The next equation, why Iran is still laying mines faster than the Navy can clear them, drops next week. The corridor is not clear yet, but we are watching every pass. Subscribe to War Vision. We do not report the war. We decode the math behind it. And the math at Hormuz right now is being solved 600 meters at a time by a helicopter older than the problem it is fixing. System 1, the AN/AQS-20A sonar mine hunting system. A torpedo-shaped towed sonar array that detects and classifies mines on the seabed using forward-looking and side-scanning sonar. It is exceptional at finding mines. It can locate a bottom mine in 50 feet of water with high precision. It can generate a position fix accurate to within a few meters. It cannot sweep influence mines. It finds them. It cannot trigger them. An influence mine does not respond to sonar. It responds to acoustic, pressure, and magnetic signatures that match its target profile. The AN/AQS-20A does not generate those signatures at the required intensity. It is a sensor, not a sweeper. Finding the mine and clearing the mine are different problems. The sonar solves the first, it does not touch the second. System 2, the remote mine hunting system. An unmanned surface vessel approximately 7 meters long, carrying a towed sonar body and a remote-operated neutralization vehicle. The neutralization vehicle places a shaped charge next to a located mine and detonates it. Two problems. First, the unmanned surface vessel is too small and too light to generate the pressure and magnetic signatures an influence mine is waiting for. Driving a 7-meter fiberglass boat over an influence mine does not trigger it. The mine is looking for a 300,000-ton tanker. It ignores the unmanned vessel entirely. Second, placing a neutralization charge requires knowing exactly where the mine is. In the silt and sediment conditions of the Persian Gulf seabed, some of the worst mine hunting conditions on Earth, bottom mines bury themselves partially over days. A position fix that was accurate yesterday may be off by enough to matter today. System 3, the MQ-8 Fire Scout unmanned helicopter. Can carry sensors, can carry some light payloads, cannot carry the Mk-105 sled. The sled weighs 7,800 pounds fully configured. The Fire Scout has a maximum payload capacity of 600 pounds. The math ends there. System 4, the Knifefish autonomous underwater vehicle, designed specifically for mine hunting in the littoral environment. Launched from a ship, it navigates independently, classifies contacts, and builds a mind map of a surveyed area. It is genuinely impressive technology, and it has the same problem as every other system on this list when it comes to influence mines. It cannot sweep them. Here is the physics that no budget has solved. An influence mine triggers on the signatures of a large, heavy object, specifically the combined acoustic, pressure, and magnetic field of a vessel, displacing thousands of tons of water. Generating that signature at sweep intensity requires physical mass and physical power that no drone, no autonomous vehicle, and no unmanned system in the current American inventory can produce. The Mk-105 sled works because it is towed by a 73-foot helicopter weighing 36,000 pounds, powered by 3 turboshaft engines generating a combined 1,140 shaft horsepower, flying 25 feet above the water at 25 knots, pulling a 1,000-foot magnetic cable loop energized at field intensity sufficient to trigger the mine's magnetic fuse. You cannot miniaturize that. You cannot autonomize it. You cannot replace the physics with software. The Navy spent $8 billion learning that lesson. The helicopter was waiting at the end of the lesson the entire time. Let us talk about the helicopter. The Sikorsky MH-53E Sea Dragon first flew in 1974. It entered service with the U.S. Navy in 1986. The airframe design traces directly to the CH-53, which first flew in 1964. The pilots flying it today were born in the early 2000s. The aircraft they are flying was designed before their parents graduated high school. Here is why it is still the only answer to the problem at Hormuz. The MH-53E is the largest helicopter in the U.S. military inventory, 99 feet long, rotor diameter of 79 feet, maximum gross weight of 73,500 pounds, 3 General Electric T64 GE416 turboshaft engines producing 4,180 shaft horsepower each, 13,140 total. That power output is not incidental. It is the minimum required to tow the Mk-105 sled through water at sweep speed while maintaining flight. The Mk-105 sled enters the water behind the helicopter on a 150-foot cable. It is a hydrofoil. It planes across the water surface rather than sinking, which keeps the magnetic cable array at the correct depth relative to the seabed for maximum field intensity. The sled itself weighs 7,800 pounds dry. In the water, the drag forces on the tow cable and sled at 25 knots approach 15,000 pounds of rearward pull. The Sea Dragon produces enough power to fly, tow 15,000 pounds of drag, and maintain controlled flight at 25 feet above wavetops in Persian Gulf conditions, which means 4 to 6 foot swells, 95-degree air temperature, and a rotor wash strong enough to create its own sea state directly below the aircraft. Nothing else in the U.S. inventory does all of that simultaneously. Now let us talk about what happens when the sled finds a mine. The Mk-105 does not detect mines. It triggers them. The helicopter flies a programmed lane, a precisely navigated GPS track across the suspected minefield. The sled follows, generating its combined acoustic, pressure, and magnetic signature package. An influence mine in the path receives signatures consistent with a large ship. Its fuse logic processes the inputs. If they match the target profile, and the MH-53E and Mk-105 system is calibrated to match the profiles of large tankers and warships, the mine fires. The detonation happens in the water, behind and below the helicopter. The shock wave propagates upward and outward. The helicopter's 25-foot altitude, combined with the 150-foot cable separation between the aircraft and the trigger point, puts the crew approximately 180 feet from the detonation. 180 feet from a mine that carries between 150 and 300 kilograms of high explosive. The Sea Dragon's crew flies this lane. They feel the detonation, they note the position, they continue to the end of the lane, turn around, and fly it again. A swept lane is not cleared after one pass. Doctrine requires multiple passes at different magnetic field intensities to account for mines calibrated for different ship signatures. One mine clearing sortie covers a lane approximately 600 meters wide and several nautical miles long. The navigable corridor at Hormuz is 6 nautical miles, roughly 11 kilometers, wide. With a 600-meter sweep lane per sortie, clearing the full width of the corridor requires a minimum of 18 to 20 separate sweep lanes, each flown multiple times. At an operational tempo of 4 to 6 sorties per day per aircraft, accounting for maintenance, crew rest, weather windows, and coordination with surface escort, clearing even a preliminary tanker lane through the strait takes a minimum of 10 to 14 days of sustained operations. And that assumes Iran is not laying more mines while the sweeping is happening. Iran is laying more mines while the sweeping is happening. Here's the cost equation that explains why. One Iranian influence mine, $50,000. Time to lay it from a fast attack boat at night, approximately 4 minutes. One MH-53E sweep sortie that clears the lane it created, $14,000 per flight hour, 3-hour sortie, $42,000 in direct operating cost, plus crew time, maintenance, ordnance handling, escort coordination. The mine costs $50,000. The sortie to clear it costs $42,000 in direct costs and 3 hours of a scarce asset's time. That is actually close to cost parity, which sounds like the Navy is winning, until you add the variable Iran controls. Iran can lay 12 mines in the time it takes the Sea Dragon to fly one 3-hour sweep sortie. That is the minimum number of mines Iran seeded across the Strait of Hormuz before the shooting started. Some estimates go higher. The exact number is classified. What is not classified is what those mines are doing to the global economy right now. 32 Aru-200 vessels sitting at anchor outside the strait, 250 oil tankers going nowhere, $40 billion in shipping revenue bleeding out of the global economy every single week. And the most powerful navy in human history is clearing those mines one at a time, slowly, carefully, with a helicopter that was designed the same year Neil Armstrong walked on the moon. Not a drone, not an autonomous underwater vehicle, not a laser-guided mine neutralization system that costs $4 million per unit. A helicopter, built in 1969, flown by pilots who were not born when the design was finalized. The United States Navy has spent the last 30 years developing technology that was supposed to make this helicopter obsolete. Billions of dollars in autonomous systems, AI-guided sensors, unmanned mine hunters specifically engineered to replace it. Every single one of those systems is sitting in port right now. The helicopter is working. Subscribe to War Vision. We do not tell you what the Navy is doing. We calculate why it has no other choice. Type sweep in the comments if you already knew the Navy's most advanced mine systems were not the ones actually clearing Hormuz. Before we get to the helicopter, we need to understand the mine. Because the reason a 1969 aircraft is doing the job a $4 million drone cannot is not a story about helicopter design. It is a story about mine design. And the mine was built first. If you want to understand why the most sophisticated naval force in history is fighting a weapon invented before the First World War, stay with me. The answer is one of the most elegant pieces of military engineering Iran has ever produced. The Strait of Hormuz is 21 nautical miles wide at its narrowest point. The actual shipping lane, the corridor where tankers must pass, is 6 nautical miles, 2 miles inbound, 2 miles outbound, 2 miles of buffer between them. In those 6 miles, Iran seeded mines before the first American missile crossed the Iranian coastline. The seeding operation did not happen overnight. Iranian mine laying began weeks before Operation Epic Fury was authorized, conducted by IRGC fast boats operating under cover of normal patrol activity. By the time the U.S. Navy understood the scale of what had been laid, the corridor was contaminated across its entire navigable width. Now consider what that means for every tanker sitting at anchor outside the strait. A single mine does not need to sink a ship to close a shipping lane. A single mine needs to sink one ship. One burning tanker blocking a 6 nautical mile corridor is enough. No insurer on Earth writes the next policy. The lane closes by fear, not by force. We covered this equation in our USS Tripoli video. The math has not changed. The Navy's mission is not to destroy every mine in the strait. The mission is to clear a lane, a verified swept corridor narrow enough to escort tankers through and wide enough that a navigational error does not put a hole back into contaminated water. That is the minimum acceptable outcome. And achieving it requires doing something the U.S. Navy has not had to do at scale since the Korean War. Sweeping mines in contested water under time pressure with a hostile force still capable of laying more. Here is where the problem compounds. Because there is not one type of mine in Hormuz. There are 3, and each type requires a different solution. And one of those types, the type Iran prioritized, has exactly one solution in the American inventory that works reliably. The helicopter built in 1969. Chillax. Let us do the math on what Iran actually put in the water. Mine type 1, the moored contact mine. The oldest design in naval warfare, a steel sphere anchored to the seabed by a cable floating at a set depth below the surface. A ship contacts the mine's firing horn, detonates it on impact. This design has been in use since the American Civil War. Simple, cheap, reliable. Cost per unit between $500 and $15,000 depending on complexity. Mine Type 2, the bottom mine. No cable, no anchor. Sits directly on the seabed in shallow water and detonates when it detects the acoustic or pressure signature of a passing ship. More expensive, harder to detect because it does not move and generates no magnetic anomaly from a mooring cable. Cost per unit, $10,000 to $50,000. Mine Type 3, the influence mine. This is the problem that a 1969 helicopter is the answer to. And to understand why, you need to understand how influence mines think. An influence mine does not wait to be touched. It waits to be triggered. Specifically, it waits for a target whose physical signature matches its program parameters. Every large ship moving through water generates 3 distinct signatures simultaneously: the acoustic signature, the sound of propellers, engines, and hull movement through the water. Each ship class has a unique acoustic fingerprint as recognizable as a voice print. The pressure signature. A large ship displaces water as it moves. That displacement creates a pressure wave detectable at range. A 300,000-ton fully loaded supertanker creates a pressure wave the mine can detect 200 meters away. The magnetic signature. Every steel-hulled ship distorts the Earth's magnetic field around it. A large vessel moving through water creates a measurable change in the local magnetic field that an influence mine's sensor can detect and classify. The influence mine waits for all 3 signatures to match its program target profile. When they do, it fires. Not on contact, not on proximity, on positive identification. Here's what that means for mine clearance. To sweep an influence mine, you do not find it and destroy it. You trigger it deliberately with a sweep system that mimics the exact signatures it is waiting for. You impersonate the target. The mine fires at the decoy instead of the ship. To do that, the sweep system must generate a loud, low-frequency acoustic signature consistent with a large ship, a pressure wave consistent with a large vessel moving at speed, a magnetic field distortion consistent with a large steel hull, all 3 simultaneously at the right intensity, moving through the water at the right speed to trigger the mine's targeting logic. And now here is the number that closes the trap Iran set. The Mk-105 airborne mine sweeping sled, the device the 1969 helicopter tows through the water, generates a magnetic field using a 1,000-foot cable loop energized by an onboard power generator. It creates acoustic disturbance using a hydroacoustic generator. It creates pressure signature using its own hydrodynamic profile moving through the water. Cost per sled, approximately $800,000. The influence mine it is triggering, $50,000, a 16-to-1 cost ratio. But unlike the SM-6 versus speedboat problem we covered in the A-10 video, where the Navy was on the losing side of the cost equation, here the math runs in the Navy's favor, because the mine fires once. The sled can make another pass. Iran buried the cost-effectiveness of its influence mines in the fact that they cannot be neutralized any other way. Let us prove that now. The U.S. Navy's mine countermeasures program has spent approximately $8 billion over the last 25 years developing systems to replace the MH-53E Sea Dragon helicopter and its towed sled. Let us go through what that money built and why none of it is doing the job at Hormuz right now.